My friends, let's solve this problem. The integral of Arctanx. Okay, if you have this kind of questions to solve, it means tan inverse of x dx. So usually I use substitution to integrate it. So I will say let alpha equals tan inverse of x. Okay? So if I call this equation 1, if I use equation 1 in this integral, I would have alpha dx. Now I can call this equation 2 alpha dx. So I have to express dx in terms of alpha because this function is now in terms of alpha. So from equation 1, if you differentiate alpha, okay, from equation 1, tan alpha, if you take the tan of both sides, it will be x. So that will be the x, the alpha is sec squared alpha, okay? Making the x equal to sec squared alpha, the alpha, okay? So we call this equation 3. Wherever we see the x, we use equation 3 in equation 2. So that gives us integral alpha. Instead of writing the x, we write sec squared alpha, the alpha, okay? Now, this is the product of two functions, so we must integrate by parts. Now, integration by parts says if you're integrating u dv, the same thing as when you subtract v du from the product of u and v. So we must be careful in our choice of v, of u and dv, because we get v from dv. What does that mean? One has to be this, the other dv, not v, dv. So alpha, that will be equal to u, so that's the alpha will be equal to du, okay? Now dv will be sec squared alpha, the alpha, okay? So that if you integrate both sides, v will be integral sec squared alpha, the alpha, which is simply tan alpha, okay? So u is alpha, v is tan alpha. So we substitute that here. That gives us uv is alpha, v is tan x, tan alpha, minus v is tan alpha, du is the alpha. Okay. So that will give us alpha tan alpha minus integral tan is sine, tan alpha is sine alpha over cosine alpha, the alpha. Now in integration, if the numerator is a derivative of the denominator, so the integral is just natural logarithm of the denominator, okay? If we post that here, we can change this to tan alpha minus, because if you differentiate cosine alpha, you get negative sin alpha, so we can put negative here, okay? Negative sine alpha over cosine alpha, the alpha. Why? Because negative, we get back that, so no changes have been made. But when you now differentiate cosine alpha, you have negative sign, so we can, but negative is positive, so we're having alpha tan alpha, negative is that what I mean. You have this positive integral negative sine alpha over cosine alpha. The alpha, I just moved a step forward so that okay. Now that gives us plus natural logarithm of cosine alpha plus constant of integration. Now let's from equation from here, let's call it equation star. Equation star, tan alpha is x. So imagine a right angle triangle So this is alpha, angle is alpha. It says that tan cosine alpha from here, tan alpha 2 is opposite over adjacent. Okay, opposite over adjacent, and it is x. So it means that opposite is x and adjacent is 1. That's why x over 1 is x. By Pythagoras theorem, here will be 1 plus x squared. Okay, square root. Now what we have here is cosine alpha. So cosine alpha is adjacent over hypotenuse, 1 over root 1 plus x squared. So we put that here. We have alpha tan alpha plus 1 over root 1 plus x squared plus constant of integration. If you like, you can change this. Okay, let's substitute this first. Alpha is tan inverse of x. Tan alpha is x, so we have, this is x tan inverse of x plus natural logarithm of 1 over square root of 1 plus x squared plus c. Now, if you like, you can change this too. This is something as x tan inverse of x negative 1 over 2 natural logarithm of 1 plus x squared plus constant of integration. This and this, why? Because you raise this to the power of negative half, negative power index half, so you bring it here, you have this. Thank you very much.